Welcome to Rogan's Network. In today's video, we'll see how to configure a native VLAN. So what is a native VLAN? The traffic without 802.1q VLAN tag is called as native VLAN. So let me rephrase it again. So any traffic that is transmitted or received on a trunk port without 802.1q VLAN tag is called as native VLAN. So the specialty of the trunk port here, it can carry the untagged traffic if you configure with the native VLAN. So remember, the native VLANs must be same on the switches participating in the trunk. The mismatched native VLAN leads to VLAN hopping, meaning that the frame sent from one VLAN will be received on a different VLAN on the other switch. So now let's understand the topology that I'm using here for this lab. So I'm going to use two modular TC switches, which is QFX, and two PCs assigned to VLAN 10 with network of 192.168.2.0/24 network. And the other two PCs, PC1 and PC2, are assigned to the network of 192.168.1.0/24, and they were not assigned to any of the VLAN. But we will try to communicate with the PC1 to PC2 using the concept of native VLAN. So the reason that I'm using the VLAN 10 to these PCs is to show you how the VLAN tag frame will work in the trunk, and the native VLAN, which is untagged frame, will work on the trunk port as well. To show that, I'm going to use the Wireshark to capture the packet going from PC3, which is present in the VLAN 10, through the trunk to the PC4, which is present in the VLAN 10 as well. So we will go ahead and try to capture the packet using Wireshark. So I'm going to capture the XE000, which is the trunk port first, and also capturing the interface XE002, which is in the VLAN 10 as well. So this is from XE002, and this is the trunk port, which is 000. And now we will go ahead and ping from PC3 to PC4 and examine the 802.1q VLAN tag first. So to do that, I'm going to PC3, ping 192.168.2.2. As you see, we are able to ping, and on the Shark, I'm going to capture the specific ping packet. And as you see, there is no VLAN tag present here, but on the other switch, as it going to the XE004, you will try to capture one packet, the last packet, which has VLAN tag of 10, because the devices were present in the VLAN 10. The packet is tagged with the VLAN 10 here. So now the concept is clear. So we are pinging from PC3 to PC4. As the packet going through the trunk port, it is actually tagged with 802.1q VLAN tag. So now we will go ahead and configure the native VLAN first, and also capture the packets using the Wireshark, and let's see how it is not tagged. To do that, first we will log into the switches and configure the native VLAN. But before configure the native VLAN, let's go ahead and verify whether the PC1 is able to communicate with the PC2, which is not assigned to any of the VLAN. 68.1.2. So the reason I'm trying to ping from the PC1 and PC2 is that when we use a Cisco devices and configure the interface which is connecting between the switches as trunk port using switch port mode trunk, the PC1 will be able to communicate with the PC2 directly without even associating any of the interfaces to the native VLAN. But in Juniper, it is important to note that we have to associate the specific interfaces to the native VLAN so that it can carry the traffic through the trunk port. So now let's go ahead and configure the native VLAN on both the switches using the native VLAN, which is the default native VLAN of 1, and we'll capture the packets from XE001 to XE000 and see whether it is tagged or not. And there is another method. We can create a native VLAN saying native VLAN with the native VLAN ID of 4094 or 777 or 999, and we'll capture the packet and see whether it is tagged or not as well. So for the first example, we are using the default VLAN of 1. To do that, let me log into the switch first using root and Juniper, CLI, figure, and to see the VLANs present. As we see, the device PC3 is associated with the VLAN 10, and also the VLAN 10 is tagged on the trunk port, which is XE000. Let's configure the native VLAN with the default native VLAN of 1, and we'll associate the interface XE001 belongs to the PC1 and also the trunk port to the native VLAN. So to do that, set interface XE001 unit 0 family Ethernet switching VLAN members 1, and we'll do the same for the trunk port, which is 000. Associate that, and now we will commit, and once done we will go ahead and configure the second switch. Root Juniper CLI here, run show VLANs, and again the PC4, which is in the VLAN 10 with XE002, is associated to the VLAN 10, and now we will configure the interface, which is XE001, as a native VLAN of 1. To do that, XE001 unit 0 family Ethernet switching VLAN member 1, and also the XE000, just the trunk port. And now we will commit it. If you see this error, you know what to do. Since it's a routed port, we will go ahead and configure as a switch port by deleting the interface XE001 as unit 0 family inet. And once done, you should be able to commit. As you see, it's completed, so we will go ahead and ping from PC1 to PC2 and see whether they were able to communicate or not. To do that, 68.1.2. So before configuring as a native VLAN, the PC1 was not able to communicate with the PC2, as you see here, but now after configuring the interface as a native VLAN, we were able to communicate from PC1 to PC2. And let's also verify whether the interfaces were assigned to the default VLAN 1. To do that, we'll type run show VLANs. As you see, we have associated the XE001, which belongs to the PC1, is associated to the VLAN 1, and also the trunk port is associated to the VLAN 1 as well. The same here using show, and it's the same here. And just to verify again, I'm just trying to ping from PC1 to PC2 on a count of 1. We were able to ping. Now let's capture the packet from XE001 and 000. To do that, click on XE000 first, and also capture XE001. To capture the packet, we will go ahead and ping once again. As you see here, the packet is going from XE001, which is not tagged, and the packet which is going through XE000 has the VLAN tag. So I believe this is an issue with the Wireshark, because I just did the same thing with the Cisco packet tracer just to see how it behaves. It was totally different for me. To show that, I'm gonna bring up the same topology, and as you see here, I have configured show interface trunk. As you see here, I just configured the native VLAN purposefully as 1. As you see here, the config is right here, and the native VLAN is 1. And to verify on the other switch, show interface trunk. As you see here, it's native VLAN 1 as well. And I just put this in the simulation mode and try to capture the packet from PC0 to PC3. As you see, the packet goes to this first switch, and when it goes to the second switch, I just captured it and saw the inbound packet. Inbound says it is not tagged. The type, if it is 0x8100, it belongs to the VLAN tag. So the type is 806, so it is not tagged, and also the outbound, which is also not tagged. So meaning that this is how the native VLAN should behave, that it is should not be tagged, but somehow Wireshark here tags it along with the 8001Q, and I have no idea what's wrong with that one, or it's I just understood it wrong. So if so, please do correct me, and I'm happy to learn from you guys as well. So a few minutes before, I said I'm going to configure the native VLAN as default native VLAN 1 and also as native VLAN 777 or 999 and capture the packet and see whether it is tagged or not. But for the first attempt itself, using the default VLAN, I can see that Wireshark is actually behaving so different here, meaning that it is actually capturing the packet with 802.1q tag. Even if I configure the native VLAN as 777, it's going to capture here as 802.1q as well. Anyhow, we have successfully configured the native VLAN, and also we were able to communicate from the PC1 to PC2 using the native VLAN. If you really wanted to create a native VLAN, so there is no such concept of set VLANs of native VLANs here. As you see, we have to create it as native and say it is native, and then we have to type VLAN ID. You can create by 777 or 999, associate those interfaces, which is XE001, XE000 to the specific native VLAN, and try to capture the packet as well. But again, as I said, it's going to capture the packet with the VLAN tag, and I don't think so it's quite impressive, or it's actually working under the native VLAN. So anyhow, we have successfully configured the native VLAN using default VLAN 1. But if you wanted to change it, you can change it and assign them. That's it for this video. Thank you so much for watching, and see you all in the next video. Until then, bye from Rogan.